Hey guys, welcome to part 1 of Visualizing New York with Knee. In this video, I'm going to show you a production workflow, and then in future videos, I'll break down each piece and explain how it works. I have a couple of public data sets on the local server. One is the New York taxicab set, and the other is a tile of OpenStreetMaps. I've actually got all of OpenStreetMaps, but I separated it by tiles. And the tile we'll be looking at coincides with the New York taxicab data set. So we're going to have a map, and then the taxicab trips split out by hour of day. So here's what it looks like to do that. Because this data is remote, I'm going to access it over an SSH connection. So starting with the taxicab dataset, here is what the data looks like. It's tab delimited values. When you download it at first, this is all open data. When you download it at first, it's comma delimited, and I've just pre-processed it a bit to make it easier for me to handle. If it were comma delimited, you'd say FC like that, and it would fix it for you. I'm going to zoom in actually. Sorry about that. Let me zoom in while we're working with the text. Okay, so we want the latitude and longitude and hour of day, which we can parse out with a regex. So FKLF, yeah, this will work. Latitude, hour of day, longitude, longitude, hour of day, latitude. So now let's interleave this with the OSM data. The OSM data is in a bit of a different format, but it's not too bad. So we've got this. Here's what that looks like. It's the tile ID, the way ID, and then the series of node points. And the node points are what we want here, and we'll set them at y equals -1. So inside these brackets, which are the interleave data set, let's process that. So if we do that, then we'll have the individual data points. We can comma split those, exchange because the latitude and longitude are in opposite order, and a -1b. So now everything is in the same format. And these two data sets are being mixed together at a 2-to-1 ratio, which is what this %2 is about. At this point, we can zoom in and see a lot. Let's go ahead and do that. The way you do this is you go over to the camera settings and you change the data translation. And in this case, we want 74. Looks like it's almost exactly 74. And then over here on the Z coordinate, we want minus 40.7. And I'm just reading off from this side. So that'll roughly center us. So we can rotate and zoom in. And we have a bunch of copies of Manhattan. And we want to compress this vertically like this by reducing the scale value. So everything at this point is going to happen visually. I'm going to zoom back out to get a sharper visual from the browser. So there we go. All right, so let's zoom in a little bit more and see what we're looking at. We have the city down here. This is the OpenStreetMaps data. And then up here, these are the taxicab pickups split vertically by hour of day. So there's 24 different planes of Manhattan, which are visible, and those represent just the taxicabs that occur, or the taxicab pickups that occurred at that particular hour. So I guess it's starting with 0 down here, midnight, 1 a.m., 2 a.m., 3 a.m., and so forth. And this will be a lot clearer once we load the full data set. So let's load 1 million instead of 100,000 points. There we go, 1 million points. So now we have just a much denser data set, and you'll notice that the OSM stuff filled out. We had been truncating that data before, and now we're not. So the other thing we can do to make this clearer is copying the y coordinate as color. So the way we do that is we simply do F, A, B, C, B. Copy column 2 to column 4. and when that loads in, we'll have a full color data set. There we go. So let's turn up the brightness so we can see this better. So we have the map down here, and then we have the taxi cab pickups over here. And we can see all those different planes. I'll separate them out a little more. Now actually, it's worth compressing these for a moment, because when you do this, you'll see, since we've aliased things to color, you'll see the hour, like the time of day bias by region, which is interesting to look at. You can see, green biasing over here. You can see some blue and purple elsewhere. This is a cool data set for a number of reasons, not just because it tells you about taxi cab pickup stuff, but also if you look at this, this is one of the most interesting things about this data. The taxi cab data gets blurry right around here, and also down here somewhat. I'll zoom out. Right around the southern part here. And the reason this happens is that New York has a bunch of tall buildings right around here, and that scatters the satellite signals. You end up getting multipath errors, and inexpensive GPS receivers don't know what to do with that. They don't filter that out. So what else is there? I mean, you can see kind of the traffic patterns to and from the airport, time-wise. So ideally, if we scale this out, we'll see heavy banding in the green and purple over here, and let's see if we see that. Oh, I guess we need to zero this. There we go. Yeah, look at that. So there's that purple stuff, the purple banding we were seeing. There's the green. You can kind of see the density change by area. One of the interesting things about the OpenStreetMaps data is that there are a lot of ways which are non-local. A way, I guess, means something like a road, but in this case, what I did to build this tile was I just took every way with any point inside this rectangle, defined by a geohash, DR5R, which is Manhattan. And I found some interesting stuff. First off, if you zoom out, this is global data, and the OSM data is global. It's not, it's not the New York taxi cab data set, but this OSM data goes everywhere in the world, which was kind of surprising, and I never quite figured out why. I think it's just that there are ways in the OSM data that contain points in New York, maybe plane flights or something. It could be that the data is incorrectly tagged. I'm not sure. And anyway, if you select all the ways with any points in New York City, what you'll end up with is a global data set. You'll see stuff from all over the place, and it's at a surprising level of detail too, which was the other thing that was intriguing. So if we go over to, I don't know, one of these points over here, it's weird things like this one little loop, stuff like that, and it was a bit surprising to see that. So again, I have no idea why this data is like this. This is the same data set, but what I've done is quantize the time down to 6-hour windows and just kind of grouped all those points in the same plane, and that makes it a bit easier to navigate. That's QB6, comma QB6 is quantized column B to values of 6. All right, and that's what it looks like to visualize stuff in Knee. I hope you enjoyed the video. Next video, I'm going to talk about how you install Knee, get it all set up, download the data sets, and ultimately we'll go through an entire series and get to this point here where this command line makes sense and this data processing workflow is something that you can do on your own machine. So I will see you next time.